Great. Well, thank you. Thank you to SuSE for letting me present here. So I'm responsible for our software ecosystem, partner enablement, a lot of our software strategy around what we're doing on Thunder X2 and the server market. So that's what I'll touch on today. But maybe first I'll this doesn't work. Let me first talk about the company just briefly. So if you've worked with us in the past, you're familiar with Cavium. So Cavium was acquired by Marvell. We completed that transaction in July. So what's interesting with Marvell is if you look at the combination of the two companies, we really are an infrastructure powerhouse in the silicon space. So Marvell is a silicon company. We build silicon in a number of core areas that touch really all elements of your infrastructure, from high-end switches to Ethernet to storage to servers that we'll be talking about here, integrated networking, just a broad array of core technology that we can leverage in these different targets in the infrastructure space. And we've always really focused on innovation and in engineering investment. So a company as a whole is 5,000 employees with a very heavy weighting to silicon development, obviously, but also software development. So we have a large number of software engineers as we drive for things like compilers, tools, upstream kernel. We're very active in the open source community. You see a number of patents and other things that we continue to drive. So well positioned in all these kind of areas. So Thunder X2 is our ARM server processor. It is based on the ARM architecture, ARM v8.1. More than just the fact that it's an alternative architecture, there's specific things that we've invested in to drive the technology. So for example, we have 32 cores per socket, and we support 4 threads per core. So especially for applications that can go parallel and leverage scaling, we pack a lot of power into an individual socket. The other thing that we're very well known for with Thunder X2 is our memory implementation. So we support 8 memory controllers per socket. So you see significant benefit in benchmarks like streams, for example, that measure memory bandwidth, and I'll talk about that in a little bit. So fundamentally what this transfers to then is application performance benefit. So Dr. Simon McIntosh Smith from University of Bristol and GW4 has been a great partner of ours and has done a number of public analysis of different applications and codes. And I know it's a little bit of an eye chart, but the real takeaway here on the upper chart is comparing Intel Skylake, Thunder X2, and Broadwell for a number of applications that are actually core to what's called Archer. Archer is one of the UK's national supercomputing sites. And these are fundamental codes in those environments where you see on the upper chart, Thunder X2 actually winning head-to-head in performance comparison. But what's really significant on the bottom is looking at a performance price combination where a Thunder X2 is 2 to 4 times better than existing x86 implementation. And this is apples to apples when you're comparing it at the different application levels. So key benefits, again, not just as an alternative, but really a fundamentally better solution. So as I talked about some of the micro benchmarks, on the left is our spec rate int measurements, comparing Thunder X2, Epic, and Skylake Gold. And on the right, streams benchmarks comparing the 3. Now these are public benchmarks actually performed independently by an organization called Serve the Home. Patrick Kennedy leads that group. He's done quite a bit of analysis on Thunder X2, but continually does reports and analysis of different architectures and different solutions. So this really highlights where we have the kind of advantages from the server side. Now this week was really a big, exciting milestone for us and really for the industry, because announced yesterday, Sandia with the Astra platform is now in the top 500. For the first time, we have an ARM server in the top 500 at 203. So Sandia and Department of Energy as a whole has been very active in helping to drive the ARM architecture and implementation. We've been working with HPE for a year and a half, starting with the Comanche program that was initially launched at ISC a year and a half ago with a number of DOE end users. And so that was a way to really prove out the technology, and now Apollo 70 is a production platform along with production Thunder X2. Would also add that in the other benchmarks, they've made a lot of progress on application benchmark, just like Simon McIntosh-Smith had done at GW4. Sandia's been doing similar things on their applications. A lot of other things going on this week for us that are quite significant from an industry standpoint. Additional customer deployments with Cray, for example, with Los Alamos, and we're part of the Shasta, the new system design. Also exciting is Los Alamos announced additional investment for accelerating some of our technology development that'll help future DOE type deployments, use cases, and workloads. Also DDN now, full commercial support for the Lustre file system. Initially with client and moving to server. And then a couple of hosted offerings. Burn Global in Europe, HPC Systems in Japan. So for customers, partners that want early access, initial code, porting, testing, now you can have easy access to hosted environment as well. So I'll just build this out on the OEM platforms. Cray's been a great partner with the Aries Interconnect. And some of the customers that I talked about that we've deployed there, and leveraging the full Cray integrated software stack, which is significant. And the first time we've had that on the ARM system, both system software as well as compilers and libraries. ATOS Bull with our CEA launch this week. Also has been another partner, and then HPE, as I mentioned, with Apollo 70. I think one of the keys here also as a takeaway is as we partner with OEMs, they're able to leverage a lot of the existing infrastructure for, say, an x86 platform and really just optimize at a motherboard level, but leverage the common existing infrastructure because of our support for standards like PCIe and other things like that. So that is also a faster route to market and a more efficient investment from our partners. So similarly, in addition to our OEM partnerships, we partner with ODMs like Gigabyte. So this is a case where with Gigabyte, for example, we build reference systems to jumpstart our ecosystem partners, end users. We put a lot of systems out into the market to do that. I'll talk a little bit more about what that enablement looks like. In other cases, ODMs may do a design for an OEM, or they may be consumed directly by a large end user. So that breadth of ecosystem offerings helps us scale to broader set of customers, use cases, optimized designs. You see slightly different designs from each of our partners here. Customer deployments, I've touched on a few of these. I think one of the things really just to call out is luminaries in the industry, influencers in HPC as you think about some of the most advanced research, most demanding kind of compute environments, and the breadth with different platforms, different geos, different use cases, but all significant configurations. Isambard is this Tier 2 HPC service in the UK that Dr. Smith has been very active in. And the other thing I'll add is, on this slide, so on the upper right, although maybe less relevant to the HPC community, we also are working with Microsoft as they move their Azure infrastructure to Thunder X2. So this is another good indication of kind of the breadth of applicability of our silicon, as well as growth from an ecosystem standpoint for more and more software applications. For Microsoft, it's not an external commercial shipment of Windows Server, it's the internal infrastructure for Azure, but workloads like search, analytics, storage, all those kinds of use cases that are key internally. On the upper left, our Catalyst UK program is interesting in that this is a deployment to 3 different institutions, universities in the UK, Leicester, Edinburgh, and Bristol. all with different charters and different target applications and areas to focus on optimization, but a broader way to expand some of the testing and code porting in particular around our platform. And then Mont Blanc 3, Mont Blanc's been very active in early ARM evaluation and deployment, and now continues to build with their work with ATOS. So one of the interesting things is you look at the ARM business model. So ARM as a company does not ship silicon. They create basically the ISA and the IP, and companies like mine, Marvell, license that IP. And then we will optimize, we can modify from a microarchitecture level, some of those things I talked about in terms of higher core count, multi-threading, how we integrate with the memory subsystem, a lot of things that will extend beyond just that basic implementation. But we stay consistent with the ISA. Now, one way to validate and confirm that across the various ARM vendors, we have a consistent implementation, is the program that ARM calls Server Ready. So this builds on some of the standards like SBSA, SBDR, other standards that ARM has instituted that we have worked with them to define. And now Server Ready gives us an ability to actually validate against a standard test suite. And one of the areas that this really helps in is think of your firmware vendors or your kernel OS developers who want to support a breadth of ARM implementations, but they only want to have to do one release, right? So we see that with the OSs like with SuSE. So I'll talk a little bit more about what we're doing with SuSE, but in SuSE's case, they support Raspberry Pi, for example, which isn't server ready, but it is an ARM architecture, but they do support other server-based releases as well. So it's really fundamental to the I think the health of the ecosystem that we've got this kind of validation program in place. So I'll talk about really kind of build up the overall software ecosystem just to give you a feel of where we are today. So you're going to see a lot of reference to standards, both in a mix of open source and commercial partners in the software space. So starting at the firmware level, we have UEFI and ACPI implementation on ARM, just like you would expect on your standard server. We have our own team driving that and driving that into UEFI, but then also we partner with AMI for commercial support around Aptio, which is their UEFI implementation, and MegaRack, which is system management. So standard out-of-band system management, BMC on every board. Again, very, very standard, but this allows us to scale. So just like we have those multiple hardware partners, we also have the multiple software partners to be able to drive how we support across the different geos and different use cases. And as I move up the stack one more layer, and I know it's a bunch of logos, but really the thing to take away is the representation here of really every commercial operating system, all of the type of infrastructure that you would look for in terms of container support with Docker and Singularity, KVM. VMware demonstrated ESXi at VMworld this year, and we did the announcement with Lustre. So you see this breadth of system software such that in a heterogeneous environment, whatever your particular requirement or preference is, we're going to have that enabled. We drive a lot of the kernel upstream enablement. We partner closely with ARM and SuSE in some cases as well for either kernel or tool chain development and optimization. So then continuing to go further up the stack as you look at development software. So different development languages, whether it's GCC or LLVM on the open source side, OpenJDK, Python, Go, and then we're really the reference platform for OpenHPC, for example. And then as you look at more the cluster management and even MPI, OpenMPI, we have full support, for example, in the HP systems with Mellanox. So again, your production with Rogue Wave for their development tools, and ARM's done a lot around the Alinea compiler and Alinea tools as well. So, again, as you've got a range of systems in your environment, as you want to do a range of porting, tuning, analysis, tools that you're used to, you're going to see on this platform. So the other thing that now as you kind of get to the top of the stack on the application side, we've been particularly active this year on driving a lot of enablement for full application stacks. So on the left here, the first three that I'll build out are really more open source. So for example, with data analytics and Hadoop, we're working with University of Michigan. They've got a large cluster of Thunder X systems that they're supporting their research infrastructure with large data analytics and evaluation within that environment. And then both chemistry, a lot of the weather codes, these are all open source codes. We've worked with ARM, we're on their GitHub. They have a large number of defined recipes for these workloads that you can go and pull down. Gives you a sense of what's the best compiler, what are the best libraries, what are the best compiler flags to use to build these reference applications in the open source space. Many of our users are using these directly. In some other cases, some are using these as a proxy for maybe applications or custom things or commercial apps that they use internally. Either way, but it's a way to really jumpstart your own porting, your own development, your own analysis. Now, this year, what you've started to see is commercial support from commercial ISVs for a platform. A good example is Cadence with Excellium. So in the EDA market, for people that are doing chip development, you typically, about 80% of your cycles are going to be on simulation. And so Excellium is Cadence's parallel simulator. And we actually just released a white paper at ARM's TechCon conference here a few weeks ago in partnership with HPE on Cadence, and the advantage that we have in this workload, because it really is a throughput engine. So this is a classic workload that benefits from the scalability of the additional cores and threads, as well as the memory bandwidth. So it's a memory-bound, parallel, very much a throughput workload that is particularly good for this platform. And in the white paper, we talk about, from a cost perspective, about 19 to 20% lower cost for that Apollo 70 in a head-to-head comparison from a Skylake implementation. So you're seeing both performance advantage and lower cost. And I have Flexera here as well, because Flexera is licensing software. So for a commercial vendor like a Cadence to monetize their software, they need to have the full support from the licensing vendor, and that's where Flexera comes into play. Just this week, we've had presentations and a variety of announcements with Ansys and Altair in particular. Ansys with Fluent. So in their release in January, there will be basically an initial, call it a research or prototype release, where they ported Fluent to Thunder X2. Very compelling performance. Altair with Radios as one of their CAE kernels. LS-DYNA, pretty well known from LSTC, has also done their port and presented on performance results. And then, also OpenFOAM is another application. But you see how we've been able to build this out, both open source and commercial, target set of segments with applications that map very well to the performance target of what we're doing with Thunder X2. So then finally, the work we've been doing with SuSE. So SuSE actually was the first operating system vendor to commercially support ARM platforms with our first generation Thunder X. We've worked very closely on both kernel and OS development. You can see on the right here, so SuSE is YES certified on the HPE platform, which is their full certification. Today we've got support with both SLAS 12 and 15 on Thunder X2. And in addition, we haven't just stopped at the OS layer. So we're also doing a lot with and support in the portfolio for storage, SuSE Manager, OpenStack is in a tech preview. So you've got the breadth of the layered products in addition to the core OS. So as a SLES customer, as a SLES user, you've got a lot of options here with the areas that we've focused on and targeted. So it's been a great partnership, one that is, as I said, SuSE is really one of the first companies to really make a full commitment to the ARM architecture, the ARM platform, and continues to invest heavily on their internal team for development, support, and optimization. And with that, I would invite you also to come join us in our booth, 1838. We've got the number of the platforms that I talked about on display, some of the references for what we're doing with Cadence and Lustre in particular, and happy to take any questions and appreciate you guys stopping by.